Today's lesson is going to be on the shape of our periodic table. So in this lesson, we're going to determine the shape of the standard periodic table and why it is viewed this way. There are several different ways to represent the periodic table, including circular, spiral, and 3D. However, we see it as a basic horizontal chart with the elements making up a certain number of rows and columns, and that's what you mostly see and is most common in all of our chemistry textbooks. Key to understanding the shape of the periodic table is to recognize that the characteristics of the atoms themselves and the relationships to one another determine the shape and patterns of this table. So as you can see here, we have the first 20 elements on our periodic table, and this shows it with their energy levels, which we've been talking about. Remember that energy levels, they're the regions around an atom's nucleus that can hold a certain number of electrons. This chart shows the number of energy levels for each element as concentric shaded rings. So if you see, for hydrogen here, it's shaded. The nucleus is in the middle, that's the big black dot, and then the electrons, that's in the first energy level. As you make your way down, you see more shaded rings. So we have 2 electrons in the first energy level with the nucleus, and then 1 on the second energy level. The electrons, which are equal to the number of protons, are the smaller dots, right? And even if we move down to sodium, which I think we talked a little bit about why there's so many in each energy level, and we're going to move forward with that as well this week. You can see that there's 2 in the first energy level with the nucleus, then you get the 8 in the second energy level, and then the 3 left over are in the third energy level. And it just moves on. The relationship between the atomic number, the energy levels, and the way electrons fill these levels determine the shape of our standard periodic table. And one thing to remember is that our atomic number, so if we look at beryllium here, is 4. That's also how many protons there are, as well as how many electrons. So you can see that we have the nucleus, and then the 2 electrons in the first energy level, and then 2 in the second. So remember, the atomic number equals protons and electrons that are in each element. And then for our next lesson tomorrow, you'll see us moving into talking about why they're in rows and columns the way they are based on their energy levels.